Hi, welcome back to Learners Academy. In this lesson, we will discuss an important concept that is used as basis for solving many mathematical problems, especially those in algebra. We will learn about graphing, which involves transforming mathematical equations into visual representations or pictures. By creating these visual pictures of data sets, we can gain a clearer understanding of the equation. Graphing allows us to visualize mathematical ideas. It transforms numbers and variables, which are a bit confusing sometimes, to an easier to understand form, the graph. Instead of problems as a series of numbers and symbols, graphing provides us a picture, enabling us to see it more clearly. The central element of our discussion today is the coordinate plane. It is an area where graphing takes place. To understand the plane, we must first revisit the number line. Recall that a number line begins at 0, with positive numbers extending to the right and negative numbers to the left, marked at each integer point. To plot the number on a number line, you place a dot on the line depending upon the value of the given number, just like 2, -3, or -2.5. Now, imagine duplicating this number line and rotating the copy 90 degrees, positioning it perpendicular to the original so that they intersect at their 0 points. This setup creates a number plane, essentially a two-dimensional extension of the number line. With a one-dimensional number line, we can plot points along the line using a single number. However, all points lie on the same line. In contrast, a two-dimensional number plane allows us to plot points anywhere within the plane, opening up a vast array of possibilities. In this two-dimensional space, plotting a point requires two numbers, known as coordinates. These coordinates work in pair to specify the exact location of a point on the plane. Consequently, the number plane is often referred to as the coordinate plane, serving as the stage for plotting coordinates. Coordinates are typically written in a specific format, two numbers enclosed in parentheses and separated by a comma. For example, 3, 2, -4, 1, 0, 2.5. Each of these represents a coordinate pair. To grasp how coordinates function, remember that our coordinate plane is formed by combining two perpendicular number lines. These lines are referred to as axes. One axis is horizontal, resembling the horizon, while the other is vertical, extending straight up and down. They are commonly known as the horizontal and vertical axes. More frequently, these axes are labeled using variable names. The horizontal axis is the x-axis, and the vertical axis is the y-axis. This naming convention offers two advantages. The first is that variable names are more flexible than horizontal and vertical, which relate to a specific orientation in space that may not always be relevant. And the second reason is that each of the two coordinate numbers is actually a variable that relates to a specific position along one of the two axes of the coordinate plane. Since these variables are typically denoted as x and y, it is logical to name the axes accordingly. In an ordered pair, the first number represents the x value, and the second represents the y value. We consistently list them in this order, x first, then y, to avoid confusion. Therefore, coordinates are often called ordered pairs because they are a pair of numbers arranged in a specific sequence, x value followed by y value. For instance, the coordinates 5, 2 indicate that x equals 5 and y equals 2. Now, let's see how to plot these coordinates on the coordinate plane. The first number in the ordered pair specifies the position along the x-axis, while the second number indicates the position along the y-axis. Together, these two numbers define a unique point on the plane. To illustrate this, let's plot the coordinates 2, 3, locate the x value, 2, on the x-axis. Instead of placing a point immediately, draw or imagine a line perpendicular to the x-axis passing through the point 2. This line represents all possible points with an x value of 2. Next, locate the y value, 3, on the y-axis. Similarly, draw or imagine a line perpendicular to the y-axis passing through the point 3. This line represents all possible points with a y value of 3. The intersection of these two lines pinpoints the exact location where x equals 2 and y equals 3. This method effectively demonstrates how the coordinate plane operates. Alternatively, there's a more intuitive method for plotting points. Start at the origin, 0, 0. Treat the coordinates as instructions for movement along the axes. For the point 2, 3, move 2 units to the right along the x-axis in positive direction. Then move 3 units up along the y-axis in positive y direction. And there you have it. The coordinates 2, 3 has been plotted on the coordinate plane. Easy, isn't it? You just have to remember the direction in which to move for x-coordinates and y-coordinates. For positive x-coordinate, you move in right direction of x-axis. For negative x-coordinate, you move to the left of x-axis, which in fact is negative x-axis. Similarly, for positive y-coordinate, you move in up direction of y-axis. For negative y-coordinate, you move in the down direction of y-axis, which in fact is negative y-axis. Let's practice this method with a few more examples. -2, 4. Start at 0, 0. Move 2 units to the left along the x-axis, which is in negative direction. Then, move 4 units up along the y-axis in positive direction. -4, -3. Start at 0, 0. Move 4 units to the left along the x-axis in negative direction. Then, move 3 units down along the y-axis, which is in negative direction. 2, -4.5. Start at 0, 0. Move 2 units to the right along the x-axis in positive direction. Then, move 4.5 units down along the y-axis in negative direction. If you have noticed, each of these points falls into a different region of the coordinate plane, known as the quadrants, defined by the two axes. These quadrants are numbered 1 through 4 for easy reference. Quadrant 1 is on the upper right region, where both x and y values are positive. Quadrant 2 is on the upper left region, where x values are negative and y values are positive. Quadrant 3 is on the lower left region, where both x and y values are negative. Quadrant 4 is on the lower right region, where x values are positive and y values are negative. These quadrants are typically labeled using Roman numerals 1, 2, 3, 4. You might wonder how this relates to basic algebra. Well, algebra involves many different types of equations and functions that are a lot easier to understand if we graph their solutions on the coordinate plane. To master these concepts, it's essential to practice plotting points and interpreting graphs. Engaging in exercises will reinforce your understanding and proficiency in graphing on the coordinate plane. Thanks for watching, and I'll see you in the next lesson.